Co-host if I should get started. Hello and welcome to our Drinking Water Wise webinars. Today's topic is climate change and impacts on drinking water safety. My name is Marika Livingston and I work for the Mississippi Rideau Source Protection Region. And I'm joined by my webinar co-hosts, Natasha, Trent, and Kelsey. You might give a wave. They're from our neighboring conservation authorities in Quinte, Lower Trent, and Cataraqui Conservation. They'll be helping to moderate the chat and provide technical support if needed. Next slide. Before we start, I'd like to go over a few housekeeping items. This webinar is going to be recorded and will be available later on YouTube. All participants are muted and we encourage you to turn your cameras off. If you would like to ask a question or send feedback, please use the chat function instead of unmuting yourself and speaking. If you're experiencing technical issues, please contact the email on the screen, and her email is natashamatthew@quinteconservation.ca. I just noticed there's a spelling error just on the slide, so it's going to be entered in the chat for you so you can reach out to her if there are any issues. Next slide, please. Thank you. All right, now that we've gotten some housekeeping out of the way, let's begin with today's webinar. We are going to go over a short presentation about the best practices for source water protection, and then we will welcome our guest speaker, Stephanie Gora, with a question period to follow shortly after. Since the early 2000s, Ontario has a multi-barrier approach to protect drinking water from source to the tap. The first step in the source protection process is protecting the surface and groundwater that supplies municipal drinking water systems. This is called source protection. The Clean Water Act, which was established in 2006, has several components to ensure that municipal drinking water is safe for consumption. The Drinking Water Source Protection Program is locally led and implemented with 38 source protection plans established across the province. And this includes local policy and protection measures to keep our drinking water safe from existing and future drinking water threats. In addition to this, to protect vulnerable drinking water, risk management measures are negotiated with people engaging in an activity that may impact this drinking water. The Ministry of Environment, Conservation and Parks and local conservation authorities work together to develop and implement source protection plans alongside numerous other stakeholders, such as our local municipalities and other provincial ministries. However, private drinking water systems are not protected by the multi-barrier approach that we just spoke about. These residents have to rely on protecting their own sources, which leads me to introduce the best practices for source water protection. In 2021, the Ministry of Environment, Conservation and Parks developed the Best Practices, which is a voluntary guidance document with a goal to aid in protecting drinking water sources that are not protected under the Clean Water Act, and a source protection plan. The document is particularly applicable to private drinking water systems, such as rural homeowners. This document walks the reader through how to identify some vulnerability in their drinking water system, how to assess the local settings, identifying potential risks, and how to manage those risks to better protect. It includes useful information to help private residents, municipalities, other agencies, and associations. Please visit the link in the chat if you want to visit and read more about this document. So now that we know what the best practices are, let's talk about why they are so important. As mentioned before, the best practices were created because there is a clear gap in drinking water protection between people who receive municipal water and those that rely on private drinking water sources. As you can see in this diagram, Trent, if you can reverse to the previous slide, please. Thank you. As you can see in this diagram, private system owners have the responsibility to ensure that their drinking water is safe by doing their own treatment and testing without being trained professionals. On the other hand, municipally treated water has trained professionals that test and treat your water to ensure it is safely distributed to your homes. Next slide, please. It is so important to consider implementing the best practices on your property. First and foremost, this will help you protect human health and the environment. You can avoid the high cost of cleaning up a contaminated drinking water source and the expensive cost of seeking out a new drinking water source, as well as increasing treatment needs. You can also extend the life of your system, appliances, and indoor plumbing, and it helps you make informed land use planning decisions. Next slide, please. The best practices guidance document outlines some best management practices on how you can better protect your drinking water. These simple yet effective measures can include things such as testing your drinking water regularly, creating an inventory of potential contamination activities that may be existing on your property or neighboring properties, implementing a protection zone around your private well or private surface water intake so that you're aware of what's going on in close proximity, visually inspecting your well and septic system annually, in addition to proper maintenance that may be required, pumping out your septic system every 3 to 5 years, depending on how many household members, and considering using eco-friendly chemical cleaning alternatives in and around your house. Another measure would be to conserve water when possible to maintain the water quantity that you may have. Disposing of hazardous waste at the appropriate locations. This can include things such as finding out when hazardous waste disposal days are hosted in your local municipality, finding out where you can drop it off and when. Inspecting and installing double-walled storage tanks for fuel oil storage, keeping it away from precipitation, proper maintenance and record keeping is also extremely important. And on a waterfront property, if you live near a surface water body and you have surface water intake, it's extremely important to make sure that there is a shoreline buffer to reduce runoff from the activities that are happening on your property. Slide, please. All right. We are thrilled to welcome Stephanie today. I'm going to take a moment to introduce Stephanie and I will turn things over to her. Stephanie works as an assistant professor at York University, where she leads the Safe and Sustainable Water Research Group and teaches courses related to water resources engineering, water process design, and engineering design principles. Her team's research is focused on light-based technologies for drinking water and wastewater treatment. The team also works on projects that aim to develop sustainable drinking water solutions for small, remote, and underserved communities, particularly in Inuit. Stephanie holds a PhD from the University of Toronto and is a registered professional engineer with the Engineers Nova Scotia and Professional Engineers of Ontario. Thank you so much for joining us today. We're going to turn things over to you. We look forward to hearing your presentation.
Thank you so much. All right, let me just try to share my screen here. Can we see it? Awesome. Okay. So again, thank you so much for having me today. And thank you all so much for showing up. I can see the chat when it comes up. So if you have any questions, feel free to drop them in there and I will answer them mostly at the end, but there's a few prompts throughout the presentation where I would really love to get your thoughts about, those questions. So do feel free to answer them when they come up. So today I'm going to be talking about the potential impacts of climate change on boil water advisories and other indicators of water safety here in Canada. So you'll see that I have a number of different names there. I'm not the only person who worked on this project. This is an ongoing sort of research program rather than a specific project. So I have a number of my graduate students like Sarah and Audrey, Amar, Reese, Marinath, and Caroline who've contributed to this work. And I've also done a lot of this work in collaboration with my colleague Usman T. Khan, who's also at Lassonde. So I think there was a pretty good introduction to who I am. The only thing I'm really going to add is that my team has recently come up with our official name, which is the Safe and Sustainable Water Research Group at York University. Um, and we do a lot of cool stuff, but I also do have other things outside of work. So I'm also a parent to Simon, partner to Andrew, and I love nature and sci-fi and music. So just thought I'd introduce that. Okay, so today a lot of what I'm going to be drawing from is a paper that we published last year. Sarah was the first author on this one, but a number of the people whose names were just presented earlier were also part of this project. So the project was how might climate change impact water safety and boil water advisories in Canada? And we were able to look at a national data set and draw some conclusions, well, maybe not conclusions, come up with some interesting, I guess, data and maybe some interesting hypotheses that we're hoping to explore further in future projects. Okay, so first off, what is a boil water advisory? I'm sure many of you are familiar with what this means, but just as a, I guess, backgrounder, a boil water advisory is an official notice that tap water should be boiled before it is consumed. It's not always because it is contaminated, but rather because it could be contaminated with pathogenic or dangerous microorganisms. The usual recommendation is a rolling boil for 1 minute, and every part of Canada has its own specific rules and policies for that. One of the most famous outbreaks of disease in Canada that drove a lot of what we've been doing in terms of boil water advisories, and it really shook up the way that a lot of different jurisdictions started to manage water safety and come up with the reasoning behind their boil water advisories, was Walkerton, Ontario. I remember seeing this in the news back in 2000. It was a very big deal. 7 people died. Well over 1,000 people were sick from E. coli in the water. Eventually, there was an inquiry. It was determined that there were all sorts of contributing factors. And this is, again, kind of what started to drive the way that different jurisdictions in Canada put together their policies toward boil water advisories and water safety more generally. So an important distinction for boil water advisories that I alluded to a little bit earlier was that boil water advisories can be reactive or precautionary. So we measure a number of different parameters and also observe different phenomena that might give rise to the potential for microbial contamination. So some of these are really obvious, right? So microbiological indicators, if we see total coliforms, which is just an indicator of there being a happy environment for microorganisms to thrive, or if we measure E. coli, which is an indicator of fecal contamination in the water, we will, a boil water advisory will be issued in basically every jurisdiction in Canada. And that's what we call a reactive or emergency boil water advisory. So something has been detected, and then we put on the boil water advisory, right? We are reacting to a specific situation. But in fact, a lot of boil water advisories that get called in Canada are actually precautionary. So what this means is that there are conditions that have been discovered. They are not necessarily, oh, we've found bacteria in the water, but it's that we have conditions that we think could potentially result in bacteria getting in the water. So if we see that there's high turbidity or particulate in the water, that suggests that our filtration system isn't functioning, and therefore there's the potential for bacteria to get in the water. If we have a low disinfectant residual, what this means is you'll probably be familiar, especially if you're in the city or a town, with the smell of chlorine when you turn on your tap. That's because we add a little bit of chlorine as it leaves the water treatment plant so that we can maintain water stability, which basically means there's no reinfection of the water as it gets to your house. So we measure that disinfectant residual at different places in the distribution system. And if that's not there, then we know we don't have that extra layer of protection. So a boil water advisory would be called because, again, we have the potential for reinfection. So similarly, we can see things like equipment breakdown or other hazards that come up that increase the potential for bacteria to be in the water. And all of this together comes under precautionary. I should note that every jurisdiction in Canada has its own set of reasons for boil water advisories. So this is not a perfect characterization. Some might include some of these things in reactive or precautionary, but this is like a general framework that is common across Canada. So as mentioned, so depending on where you are in Canada, usually the chief public health officer or an equivalent will be responsible in the end for calling a boil water advisory, deciding that a boil water advisory should be called, but it does change from place to place. Usually the reasons for boil water advisories, again, they do shift from jurisdiction to jurisdiction, but they're usually based on adverse water quality findings or awareness of potential contamination hazards, just like I mentioned in the previous slide. Now, what makes things interesting for people, or interesting, I mean that difficult sometimes for people like me who are doing research, is that although some jurisdictions provide all of their information, any boil water advisory that's ever happened, or at least within a set period of time, is posted online with a reason, location, date. So that makes it really easy for someone like me, but even anyone really, to go in and see what the history of boil water advisories might be in an area, get a sense of why these things are happening. But this isn't necessarily required all over Canada. So in some places you either have to dig a bit more. So in Ontario, you often can find the data, but it's a bit of a process. And then other places they don't put anything online at all. So hopefully, though, many of these jurisdictions, whether or not they publish their information on their own websites, many of them report it to what's called the Canadian Network for Public Health Intelligence, which you'll see written as CINFI for the rest of my presentation. So this is a group, it falls under a few different levels of public health at the federal level. And what they do is they collect this information. They do some level of preliminary analysis. They also clean the data to some degree. I was lucky enough to connect with them very early in my professorship. So basically, the first few months, they were the first people who decided to work with me, which I really appreciate. And they gave us a data set we could look at that spanned most of the country. Okay, so after that, I was just hoping to get a sense of whether or not anyone in the crowd has experienced a boil water advisory. Feel free if you want to, unmute and say it out loud, but you can also type in the chat. Okay, not personally. So I'm glad we have a crowd that hasn't had a lot of boil water advisories. I have experienced boil water advisories a few times. Yeah, so Sarah's mentioning she's had quite a few. My partner is from rural New Brunswick, and he's from a tourist town in southern New Brunswick. And they are on a boil water advisory almost every summer, which as a community that relies on tourism for basically everything, having to boil water or just not provide water and have to put up a sign on the restaurant door saying that there's a boil water advisory, it can be hugely detrimental to their business and to their way of life. Similarly, my team does a lot of work up in Nunavut, and we've been there for a couple of boil water advisories in Iqaluit and also in Cambridge Bay. So it's amazing how much work it is once you realize that your water is unsafe. It's a lot of anxiety and there's a lot of expense for getting water. And for some reason, whenever there's a boil water advisory, I am just so thirsty. And it just feels like all we're doing is buying bottled water. So it's, of course, there's the opportunity for disease, but there's also huge disruption just in your faith in your water system and also just in your time and money. Okay, I want to give you a bit more information about the data. I'm not going to roll through all of this, but I do want to make sure that it's available to you because one of the important things with this study is that I think, as I mentioned, we really struggled to, come up with definitive conclusions, and that's because of certain aspects of the data. But we did find some really interesting trends and suggestions for future research. So basically, the information comes from CINFI. They gave us information that spans 16 years. There were nearly 10,000 individual boil water advisories that were listed in this data set. So this data encompassed all of Canada, but some provinces and territories don't report, and they didn't tell us who. So we didn't know because they anonymized it, which is fair. I can understand why, for example, the village where my partner is from doesn't want the whole world to know that they have a boil water advisory every summer because it could harm their tourism. So I get it, but it did make it really, really difficult for us to draw some important conclusions to anything. But nonetheless, we didn't have information about the province or territory. We hear a lot about boil water advisories in Indigenous communities, as we rightly should, because that's a huge problem. We did not have any information whether the communities, whether the boil water advisories that we had in our data set were from Indigenous or settler communities, though I will note that there were far more communities represented in the data set than there are First Nations in Canada. So we know that it was not just in Indigenous communities, it was also in communities of all sorts across the country. And we also didn't know region. This is really important because one of the things we wanted to do was look at the potential impacts of climate change on boil water advisories. And climate change looks different if you're in Newfoundland than it does if you're in Winnipeg, right? So these were some pretty important limitations. But thankfully, there was so much data over a good period of time and a really deep data set. So we still could look into this and we could still do some meaningful analysis. We did have to make one really important decision, which we did clear with our collaborator, which was that they had provided a primary and a secondary reason for each boil water advisory. You can imagine how much work that is. They went through the records, they applied these themselves. But in order to do the kinds of analyses we wanted to do, we couldn't have it with the primary secondary. So we just made a decision that if the primary reason had been called not applicable, which a substantial portion of them had, then we would go with the secondary reason, and otherwise we would go with the primary reason. Okay, so we did a bunch of different data analyses. We did everything in an open source data analysis program called R. And we did a number of different statistics, but some of the other members of my team did some work with ARIMA and Mankandal. These are two tests that are used to determine trends over time and also to see if the trends over time have a seasonal component, like are they influenced by changes between winter, spring, summer, and fall, or are they not influenced by those things? So that's what we were trying to look at with these statistics. And yeah. We also did a very in-depth literature review, a systematic review of academic literature, which we conducted over the period of 2020 and 2022. So it included information from before that, but that's when we were doing our literature review. And we also supplemented that with gray literature, which is basically government literature, consultant reports, other documents prepared by experts that are not in the peer-reviewed literature. We also did some expert interviews with climate and engineering professionals, mostly to kind of vet the general findings that we were finding and see if that kind of matched up with what they've observed. And also sometimes so that we could get access to different types of gray literature. And I would consider this literature review up to date, basically to April 2023. So it does not include any papers that were published after that. And but still, there was a lot to go on, it turns out. So anyway, the first thing we looked at was something that we pretty much knew before we started, which was what is the influence of population size on the number of boil water advisories? So not unexpectedly, or rather, we totally expected to see that it was more common in smaller communities, and in fact, it is. Smaller communities experience a vastly disproportionate number of boil water advisories compared to larger communities. There's lots of reasons for this. We also broke this down by primary reason, and I know that these are a little bit small, but it is, visible that there is one type of boil water advisory that just really dominates things, basically at any size community. And this is line break or pressure loss. So line break means a pipe break, and pressure loss can result from a broken pipe, but it can also result from something going wrong at the water treatment plant, like with the pumping system or the treatment plant being off for some reason. So this was a very common cause of the boil water advisories in the SINFI database, and it is one of those reactive boil water advisory types, as I explained previously. So we looked at the impact of source water type on boil water advisory, and basically what we found is that groundwater systems are overrepresented. So it's not that groundwater systems are the only ones that have boil water advisories, but if you look at the number of communities of a certain size, which is above 300 people, which is all that we have in this data from the biennial drinking water plant survey, and we compare that to that same group in our SINFI database, there's more than 11% of the boil water advisories in the SINFI database are in groundwater systems, but only 11% of people use groundwater in Canada. So that means that there's a disproportionate number of groundwater systems experiencing boil water advisories. We also looked at long-term boil water advisories, and here we have it broken out by population size. And again, we see that there's a lot more in the smaller communities. It's interesting also to see just the length of those boil water advisories. So 1-day boil water advisory is irritating. A week-long one is, starting to become a problem. If you're on the boil water advisory for 60 days, that's 2 months. Especially if that happens to fall within 2 really important months for the town or for you, that can become quite problematic. This is where people start to shift their behavior, is when we've got a boil water advisory that's on for a really long time. And we still saw like a very large number of boil water advisories that lasted up to a year, up to 15 years. So that's a really long time. So in terms of the causes, as I mentioned previously, those line pipe breaks and pressure loss are the most common ones. Doesn't matter what population size we're looking at, those are the most common. There's also a substantial number of these boil water advisories that are related to poor distributed drinking water quality. So with that, what we're talking about is stuff like we've seen an exceedance of the maximum acceptable concentration of something important. We've seen a lack of disinfectant residual, like I explained previously. We've measured turbidity or total coliforms or E. coli in the water. So that is another fairly common cause of boil water advisories. And those are the 2 categories that I'm going to dig into a little bit further later in this presentation. And we see a very similar trend when we look at repeated boil water advisories. So before we were looking at the long ones, and here we're looking at the ones that keep happening. And you can see that once again, they're more common in smaller communities. And once again, that pipeline break and pressure loss is the most common reason for things happening. So some conclusions of that initial boil water data analysis: small communities experience more frequent, long-term, and repeated boil water advisories than larger communities. Most of the boil water advisories that were issued in Canada between 2005 and 2020 were related to the failure of distribution system infrastructure. So it's mostly happening after we leave the water treatment plant. Poor distributed water quality also contributed to many of these boil water advisories. And I guess that's all my conclusions. There we go. Okay, so those are the main conclusions from that part. So at this point, we haven't even talked about climate change. We're just looking back and saying kind of what are the characteristics of these systems and which are the most common types of boil water advisories. But the title of this session promised climate change, and don't worry, we did look into that. Our next step was to conduct an in-depth literature review, trying to understand what are the potential impacts of climate change on water infrastructure. And then what we did, and I'll talk about it after the climate change section, is we did those more advanced statistics to try to see if we could find any trends related to the potential issues related to climate change on the boil water advisory data set that we got from SINFI. So climate change and water safety. This is not actually a new topic. It's a very hot topic right now. It's something that you see everywhere if you're working in water. But what kind of struck me when I was going through this is that we were talking about this, not just in the past 2 or 3 years. And in fact, we've actually been talking about this since 2006 at the very, like it's not a new topic, but it is something that has recently become of greater concern. And that's because we are seeing these impacts of climate change, right? We're seeing them day to day in our own lives. And so it's becoming something that everyone's aware of and everyone's working towards addressing. All right, so what I'm going to do is roll through a couple different, I guess, categories of climate change impacts and try to pull out some of the really important takeaways from the analysis we did. So kind of the basic thing with climate change is increasing temperature and then the subsequent impacts on all sorts of other natural phenomena. So we looked first, of course, at increasing temperatures. So each of these phenomena had observed or projected changes on the environment, and from that, potential impacts on drinking water quality and infrastructure. So basically, increased temperatures will have direct impacts on source water quality and quantity, and they could also negatively impact distributed water quality. And that's because increased temperature can result in a happier environment for bacteria, but it can also lead to things like, not all, almost all chemical reactions occur more quickly when it's warmer. And that can increase, for example, the rate of chlorine decay and therefore the likelihood that we are going to see a low chlorine residual in our tap water. All right, so those increases in temperature are also likely to decrease our snow and ice cover in Canada. And less snow and ice is likely to result in changes to that seasonal distribution of floods, right? So if we're seeing snow melting earlier, then if we're having a flood associated with the spring freshet or the spring melt, it's going to be happening at a different time of year, generally earlier. And then floods have a lot of negative implications on drinking water quality, on infrastructure because of like just things like, pump houses getting flooded and all sorts of problems that can come with floods. So a lot of the changes in snow and ice cover that we have already observed and are likely to observe more of in the future mostly have the impact of changing the seasonality of when floods happen, and in some cases, changing the intensity of those floods. All right, coastal flooding. A lot of work has gone into understanding coastal flooding. And we've seen issues with water, wastewater infrastructure related to coastal flooding already. So there was an incident in Lunenburg, Nova Scotia, if you've ever had a chance to visit, very beautiful place, where their wastewater treatment system got flooded. I don't know that it was definitively linked with climate change. It was due to a storm, and most of those big storms are likely to be linked with increased with changes due to climate change. But in any case, increased coastal flooding, whatever its cause, is likely to negatively impact source water quality because it's, of course, bringing in salinity, but can also disrupt and damage infrastructure. And sorry, I didn't finish that story from Lunenburg, which is that it got flooded and a bunch of the pipes failed. So what happened is they recently put in this beautiful wastewater treatment system. It got flooded, and then they were once again putting wastewater out to the environment, untreated, for a time. Okay, so wildfires are increasing kind of all over Canada. We're lucky enough in Southern Ontario, it's not something we've seen a lot of, but I know that many people I know in the north and in Nova Scotia and in BC have had to deal with a lot of this more recently. So forest fires have negative short and long-term impacts on surface water quality. So when trees burn, different types of things, both, especially organic matter, but other things like metals, etc., are deposited onto the soil. But it also changes the way the water moves across the soil and the likelihood of that stuff getting picked up and washed into the water source. And so that in and of itself, those contaminants could pose a bit of a risk to people. But what's even more likely to happen is to see a disruption in the water treatment processes. So we design our water treatment systems to treat a certain kind of water. And if that water quality changes, whether that change happens long term or if it happens really in short term, like with a forest fire, it can mean that our water treatment system no longer operates the way it was designed to operate. So permafrost degradation, not a major concern here in Southern Ontario, but up in Cambridge Bay and other parts of Nunavut where my team does some work, this is a major concern. We've already seen negative impacts on source water quality in northern communities. So I know that we've seen increases in natural organic matter, which is kind of that like brown colored stuff that's in the water. This can lead to all sorts of downstream challenges with water treatment. I've also been in touch with another professor at York who is helping a First Nations community in Northwest Territories deal with a series of cyanobacterial blooms that are occurring in their drinking water source. So that may or may not be linked to that increase in natural organic matter and other nutrients that's resulting from permafrost. So even though we don't know everything perfectly with permafrost, we know that it's already having impacts, and it's already having impacts on things like source water quality and whether or not that water is now treatable in the same way it was previously. We've also seen things in Nunavut such as sort of sinkholes that develop because of permafrost heaving, impacting just like literally the water treatment plant, like the floor falling out. And that's the thing with permafrost, is that there is heaving, that it is sometimes very difficult to predict. And so that can be extremely dangerous for infrastructure. All right, so I've already touched on flooding a few times. Flooding due to extreme weather is the kind of thing that we've been seeing a lot in Southern Ontario. We had two major floods in Toronto this past summer, especially the one on, I think it was July 16th, where basically everything came to a standstill for a day. We had something like almost 100 millimeters of rain in anyway, it was nuts. There's a lot of flooding. So that frequent and intense precipitation negatively impacts our source water because that huge flush of water coming really quickly can pull up a lot of pollutants from the surface. Whether we have an urban surface, so like pavement, where there's a bunch of stuff deposited, all that's going to wash right into the source water. But even if we have an agricultural or a more naturalized environment, it can still cause these increased velocities, which means that more stuff gets picked up and more stuff gets washed into the water source. And of course, any flood can result in infrastructure damage of any sort, like of all sorts of types of infrastructure. So these can also have an impact. Drought. Drought, of course, is the opposite, basically, of all this flooding. Droughts can cause temporary spikes in contamination in surface water. A lot of this happens because there are a couple different reasons, but two of the ones that really stood out to me were that if there's a drought, we don't see that wash off of those surfaces into the source water very frequently. So if we have a long period where things are getting deposited, and then we have a big rain, or even not that big of a rain, but something that does break the drought, all of that sediment and all of that other bunch of pollutants that has built up over time gets suddenly washed into the water source, which can cause a huge spike in those things. Another thing that we're very lucky in most of Canada, this is not something that we see too much of, but there were some really interesting studies from Las Vegas and Arizona talking about this. And they were talking about how in some places, a substantial portion of, say, the river that they draw the water from is supplemented by treated wastewater. But then when there's a drought, a higher proportion of that water is related to that wastewater outfall. So that can change the water quality as well. So interesting stuff. So we looked at all those things. Those are the number, like the 6 most common ones that we saw. And then we kind of pulled them into which different impacts are they having on the different elements of the water system. And then we saw there's connections to both those precautionary boil water advisories and the emergency ones. And altogether, what we can generally conclude is that there's going to be an increased water safety risk in small communities because there's all these different things happening that are increasing general vulnerability to water safety issues and the kinds of things that result in both precautionary and emergency boil water advisories. Okay. So another little question. Have you observed any changes to your water system or water quality that might be related to climate change? So I know that many people in this region use their own groundwater sources, but that doesn't matter. Anything that you observed in your own life that might be related to climate change. So I know myself living in Toronto, we've definitely seen the influence of those extreme storms that we've been having, and that impacts our source water quality um, and results in the need to basically adjust what's going on to make sure that we're accounting for it. We're very lucky in Toronto. We pull from a deep part of Lake Ontario, and so we have very, very high quality water to start with, but it's still something that has to be managed. Okay. So now I want to pull, oh yeah, Sarah, very good point. Those harmful algal blooms. So I'll give it another second since we're getting some notes in the chat right now. So in the chat, I'm seeing more frequent harmful algal blooms, which are the same thing as cyanobacterial blooms in source water, low water levels, and areas that have never had major storms are now getting tornadoes. That's like so scary. But yeah, tornadoes is another thing that could obviously damage most above ground infrastructure. So pretty scary. Extended unplanned power outages. Yep. As a result of severe storms. Yeah, we are seeing a lot more of that. One of the interesting ones, kind of one of those like, I guess, secondary results. One that I was talking to a colleague in Nova Scotia. I used to live out in Nova Scotia. And there was a concern during one of the bigger storms a couple of years ago where the little bit of land that connects Nova Scotia to the rest of Canada, so like between New Brunswick and Nova Scotia, they were concerned that that was going to flood, right? So people couldn't pass. And that's annoying if you're going to see your family in a different province, but what they were really worried about was things like the chlorine delivery being disrupted. So running out of chlorine at the water treatment plants because they're used to having it supplied through the rail line all the time. And if the rail line was damaged, they wouldn't be able to get it. So I haven't personally observed that, but I thought that was an interesting and kind of scary anecdote. Okay, so now I'd like to bring these two concepts together. So we have this boil water advisory data set that talks about the last 15 years. We have seen climate changes in the last 15 years. So we thought, can we see any trends over time as these types of changes have been happening? So I just wanted to remind everyone about the main causes of, we're going to look at long-term boil water advisories here, but just boil water advisories generally. Honestly, just if we looked at them all together, if we looked at them long-term, if we looked at them as repeats, we had the same major reasons for why we were seeing boil water advisories. Mostly line or pipe breaks and pressure loss, as well as poor distributed water quality. So in order to really do this analysis, we had to break things down. Like, what does line break or pressure loss really mean? So this we dug back into some of those secondary reasons because we were like, we need to understand this a bit better. So if we looked at that, we found that of this line break or pressure loss category, about 38% were related to planned system maintenance. So this is something, now this may not be a very long-term plan. It may have just been a plan that developed, yesterday. But the point is that this didn't happen suddenly. There was some, they were proactively addressing something in the water system. And so this is something that they put the boil water advisory on before they started doing work, which is common. So if you're fixing a pipe, usually you have to isolate that pipe section, and then the people who could be impacted downstream are on a boil water advisory, some kind of precautionary notice until the construction is completed. So that was, 38%. So the biggest proportion. 23% was related to treatment or distribution equipment failure. So that could be an actual pipe break, or it could be something at the water treatment plant. In 21% of cases, there was no secondary reason given, so we just had to assume it meant that there was some sort of line break that resulted in pressure loss. We also saw 15% related to power outage, and then 2% that were related to contamination during construction, repair, or operation. So this is where those statistics came in. So we looked at a few of these categories, and we tried to pull out the long-term trend component. So we see trend component, that's the long-term trend, and separate it out from the seasonal trend. We do this because if we don't separate them out, sometimes we think we see something, but it's actually due to a seasonal change. So statistically, we want to isolate those two different kinds of trends so that we can better understand what's going on. So I see a question in the chat. I'm going to answer that very shortly, but thank you for that because that's a really good point. Okay, so we looked at the long-term trend. We did see that there was a long-term increase for the most part in infrastructure failure damage, planned system maintenance, despite that little dip. I'm sure we all can guess where that dip in planned maintenance happened in 2020. But a generally increasing trend in planned system maintenance as well as in power outage. Now, it's unclear because we don't have that regional data and it's all anonymized. It could be climate change, and based on what we know about climate change happening, there's actually, it seems quite likely that there's some contribution happening here. We think about power outage, we were just talking about increased storms. We're more likely to see power outages, but it could also be aging infrastructure. You know what I mean? So there's like a little bit of, are we actually sure exactly what's going on? But again, given what we know about climate change, it seems likely. Another thing that could be kind of muddying the waters is there are different boil water advisory policies in different jurisdictions and over time. So some jurisdictions have updated which types of things they call boil water advisories for. So it is feasible that maybe they didn't used to call one for planned system maintenance, but now they do. And also one of the really complicating factors in some of this is that we've had a few more jurisdictions join the database over time, so there could be something there. Nonetheless, these trends are pretty convincing. And given what we know about climate change, it seems likely there's some impact there. We also looked at seasonal trends, and the seasonal trends that we saw in the boil water advisories are in line with what we'd expect for most seasonal climate trends in southern Canada. So we see more pipe damage occurring in late winter, early spring, when things are warming up. We see more system maintenance performed in summer and fall, especially, we can understand why if we have planned maintenance, it'd be more likely to happen in the warmer months when it's easier to dig and it's safer to work. And those power outages are more likely to occur in summer, which is when we also see a lot of our major convective storms. So here is that more detailed statistical analysis of the seasonal trends. A few things to see here. So in all of these graphs, the lighter purple line means further back in time, and the darker lines mean more recently. So we can see that there does appear, especially in that power outage bit, to have been a change in kind of when these things are happening, in the seasonality of what's going on. So again, there are some complicating factors. We can't say definitively that like this is happening due to climate change and that's the only thing impacting it. But it is interesting to see that there is a change in seasonality over time, something to track. We also looked at distributed water quality. So there were some changes over time. So there were some statistically significant trends. But these ones, there weren't as many data points. So there's a lot of boil water advisories called because of those distribution system issues. This water quality side, it's like the next biggest reason for boil water advisories, but it's still a lot smaller. So we don't have the numbers we did previously, which makes it difficult to do any kind of statistical analysis. But there was some suggestion of some increase. Where we saw something that was maybe a bit easier to explain was in these seasonal trends. So we see with E. coli and total coliforms, 2 measures of bacteria. We do see increased likelihood of a boil water advisory being called for these reasons in the summer, which is when it's warmer, and we'd be more likely to see warmer temperatures in the distribution system and therefore more likely to see regrowth of bacteria. We had some suggestion of maybe higher turbidity in the spring, which again makes sense because a lot of our water sources are more impacted by turbidity as snow melts and we have that spring freshet that brings water, or rather brings solids into the water from the environment. Another good point in that, I'm just going to turn off the chat just for now because I'm getting distracted by these very good questions. And then we also saw a bit of a seasonal trend with disinfection residual. All right, so we also looked at those seasonal components on a more statistical level. And once again, we did see some shifts in that seasonality. But again, we are working with a smaller number of data points here, so it's a little bit trickier. Okay, so some of our conclusions here. Oops, there we go. There was some evidence of long-term trends, and this suggests that there's still more analysis needed, and don't worry, we are doing some of that. I'm going to show those slides next. But just knowing that there's the possibility of these longer-term trends, we need to start taking this into account when we're designing things. Just knowing that things are in some ways like getting worse. But if we think about something like, for example, source water changes, we know they're happening. We have to start designing our systems to be more flexible to account for that. And those seasonal trends exist in some of the reasons for boil water advisories. And again, this is something that should be kept top of mind when we're talking about resilience. So we need to increase the flexibility in what we're doing so that we can, I guess react, but proactively start to address some of these challenges, knowing that there's some changes happening. Okay, I already talked about the limitations, and I saw a really good comment about that in the questions, so I will come back to this. So there's the regional and local trend issue, but some of the other things that we were unfortunately not able to link yet were things like existing and projected future regional environmental conditions. We were not able to cross-reference the data with capital operation and costing data, which could give us some really interesting information about where action is being taken. We also didn't have information about the individual treatment systems or the distribution infrastructure or about operator training and certification, which can have a huge impact. Okay, so I actually want to take a moment to respond to some of those questions because I really did like them. Okay, so Julie, I see, is it possible that seasonal trends could be due to boil water advisories being issued for seasonal drinking water systems? This may be a limitation. This is a very good point. Thankfully, we did get a data set that only included systems that operated all year. So those were already taken out before it was given to us, but that's a really good point. And I suspect that had we included that, we would have seen even more of a seasonal trend, but that would also have been exactly related to what you're suggesting here. Have I seen a boil water advisory due to planned maintenance of the distribution system? And yes, boil water advisories are regularly called because of planned maintenance. So that's where it's not really a surprise to anyone. The notice will be sent out ahead of time that work's going to be happening here and boil your water until it's done. And so yes, this is something that does occur. Okay, I'm going to leave it at that for now. And I want to move on to kind of what we're doing now and how we're trying to incorporate this and a bit more complexity into what we're looking at for water safety. So boil water advisories are not the only or best indicator of water safety. There's all sorts of other stuff in our water that we're concerned about, and some of those things are also likely to be impacted by climate changes. So things like metals, lead and copper corrosion in on-site plumbing systems, legacy contamination from mining and industrial activities. We've seen a lot of this be a huge problem in the north. Operational hazards, lived experience of users and operational staff. And so when we talk about water safety, it's not just about bacteria, although that's a really, really important one. And the number one thing we have to make sure is that people don't get sick with like disease, but there are all the other things that have to be considered. So what we're trying to do is find different ways of thinking about and modeling water safety. So we want to incorporate a lot of different types of information: boil water advisory records, chemical and physical water quality data, climate data, treatment system information, records. And the goal is to make sure that we have a better, more holistic view of water safety and understand some things are going to be climate change related, but some things are also going to be related to policy, right? So a jurisdiction has changed a rule or they've implemented a new treatment standard. That's going to have an impact on water safety, and trying to be able to pinpoint where that's what's going on is really helpful, because if it's made a positive change, that's one of those opportunities that maybe another jurisdiction can take and say, oh, well, we're going to implement the same change and hopefully we'll also see this positive impact on water safety. And the ultimate goal is more resilient and effective water systems so that everyone has safe water. So some of that work is related to a really nice data set from Newfoundland and Labrador. So Newfoundland is one of the provinces that does keep a in-depth records about water quality. And some of this is related to their boil water advisories. This province, unfortunately, has a lot of boil water advisories. They've made a lot of changes over time that have reduced the number, but it's still quite an issue. They have a really nice system whereby they've categorized all their boil water advisories very clearly, so with reasons. And this makes it a lot easier to analyze. So some of the ones we looked at here, sorry. I plotted everything here, just all the different reasons, and we had data from 2000 to 2023 for this one. And we see kind of similar trends as we saw with the national data set, most notably that a lot of the boil water advisories are due to distribution system issues. And you'll see that maintenance and repairs. It's not really clear if that's planned or reactive maintenance and repairs, but it is the leading cause. And we also see a number of boil water advisories associated with water quality related reasons. So disentangling those things, though, as I was mentioning, it's complicated, right? There's might be climate change, but there could also be other things. So this is an example of a policy and rule-based change. So reason A that they have in Newfoundland is called water supply has no disinfection system. So this would be like literally we're just pumping out a lake and bringing it to people's homes. So in 2000, I guess about 34 communities were on boil water advisories because of this reason. But a change was implemented, and now the number has gone down to, almost negligible. We don't even have it up to 2023. There have not been any boil water advisories in the province related to this since 2016. So that's a policy change, though. It's not like the water just suddenly became better in 1 year, right? They made a decision. They went out, they checked all the systems, determined where the problem was, put those communities on a boil water advisory until that was fixed, and then they took them off the boil water advisory. So that's an example of, again, a change that was made by the jurisdiction to improve water safety, and it was like a policy or rule-based change. But sometimes it's not as easy to figure out what's going on. So this is just a heat map, and it's showing all the reasons for the boil water advisories, the different population ranges. We see that there's some sort of seasonal component going on. There's a population component going on. It's really hard to pull some of this apart, because if it was just policy, we wouldn't probably see some of this seasonal stuff, right? It's not like the community is more likely to not have a disinfection system in the summer than in the fall, right? So there's a lot going on. So we started to do some basic visual analysis, and my student Marinath has just initiated some more detailed statistical analysis of this data set. So these are her preliminary graphs. They may change as we kind of refine our analysis, but I thought they were interesting, so I thought I'd present them. Okay, so looking at that first one, water distribution system is undergoing maintenance and repairs. If we look at it even just visually, we don't see, and you see the colors are representing the different months. We do seem to see an increasing trend over time. Maybe they're doing a better job at fixing things, but maybe things are breaking more often. Maybe things are breaking more often because the climate is changing, or maybe because it's getting old. This blip in 2023, it's actually that our data set ended at September. So that's why we don't see as much there. But if we look at total coliforms detected and confirmed in a repeat sample, we see that there's a lot of this green color. This is the summer and early fall. So there does seem to be a seasonal component. It looks like things increased over time, but then started to decrease. Is it improved treatment? Is it improved policy? It's not, we're not sure yet, but that's where we're looking right now. So another place where we're trying to understand water safety a bit more holistically is with our team in Cambridge Bay, Nunavut. I think we have one more picture, but it doesn't matter. We'll get to it. So in this case, we don't have a huge boil water advisory data set because that doesn't exist for the territory. But what we do have is really good relationships with people in the territory, and like a strong interest and willingness to participate in understanding where the water safety hazards are, what they are, and in participating actively in the science that we're doing. So you see the lady in red in that one picture is my student Caroline, and flanking her are some youth interns who we trained and hired for the summer to take water samples for us, and they did an amazing job. And again, people are really, really eager to understand what's going on. So that brings in that component of people feeling safe, but also contributing to their own water safety. But we're also looking at kind of the basics of the water quality there. But one of the challenges that we're finding is that there is not a lot of data at all in Cambridge Bay. So this is just showing manganese. I know this isn't boil water advisories, but it's what we have more information about. And we can see that they do have a couple of readings every year from 2017 to 2023. We also see that there was a decrease over time. That's because they installed a new system between 2017 and 2018 that was able to remove some of the manganese, and then they updated it later to make sure it was fully working. So that shows that something changed and we know why. But then sometimes it's just we have so little information in our systems that we're working with up north that it's really impossible for us to figure out any seasonal or long-term water quality changes with what's there. So, I think that the strength in Newfoundland and Labrador is that they have this amazing data set, and they have, a team dedicated to managing all their water quality data. So we have that information, and we can make those kind of statistical analyses. But the plus side when we're working in Nunavut is we just have all this participation and interest from people. So that's been really helpful doing our work and understanding the water safety challenges there. Okay, so I'm going to end it there. I hope that was interesting, and I am very open to answering any questions that you might have about any of the aspects of the work that I've talked about today.
Thank you, Stephanie. I hope everybody can hear me okay. We are going to jump into some of the pre-submitted questions. So Stephanie, just before we get into those, thank you so much for your time and attention with the presentation. It was excellent, very helpful and informative, but also really important work that you and your team are doing.
Thanks.
All right, so these are pre-submitted questions that we received upon registration. So I'll take us through some of those. Right, so the first question, any insights on emergency management and drinking water to climate change?
Yeah, so I'm not an emergency management specialist, so I don't want to speak out of turn. However, I would say that in general, people are understanding the need for emergency management in a way that they maybe did not before. I'm reminded of an excellent presentation I saw a few years ago by representatives from the city of Moncton. They had a cyanobacterial bloom or harmful algal bloom in their backup water supply. So not the one that they were using actively, but the one that they would rely on if something happened to their main water supply. And they had to develop an emergency planning system for the possibility of there being cyanotoxins in their drinking water. And it was quite involved. It was an excellent presentation. And if there's somebody who wants to connect about that, please feel free to contact me through the team that's putting on the webinar today. And I'm happy to connect you with people from the city of Moncton who could speak to that. But basically, it was a lot more than they thought. It's not just a matter of having the extra treatment. You have to have a plan for providing safe drinking water for people. You have to have a plan for making people aware of what's going on, right? A lot of people know what a boil water advisory is, but they may not understand that it's not the same thing as a do not consume, right? If you have cyanotoxins in your water, you don't want to boil it because that's actually might concentrate things. Because boiling it's not going to make a difference. You're not getting rid of the toxin. So a lot of it is, being organized, being able to manage logistics, but also being able to manage communication, which is a really, really huge part. And also water is very personal to people, right? You get sick quickly if there's something wrong with your water. You feed your children food and give them drink and bathe them in the water that, comes out of your tap. And so you don't want people to get scared, but you also want to make sure that they're protected. So those are my insights for what they're worth, but I'd be delighted to connect anyone who wants to connect to people who have this lived experience and expertise, if they're interested.
Thank you very much. So the next question, what are the links between cyanobacterial outbreaks, climate change, and drinking water from both surface and groundwater?
Okay, great. So I think the first distinction is that we are extremely unlikely to see a cyanobacterial bloom in groundwater just because the access to oxygen and other nutrients is very limited. I'm not going to say like absolutely never, not even in a super shallow well that has a huge impact from surface water. I could imagine a circumstance where it could happen, but what we're mostly concerned about is surface water. There are two main drivers for cyanobacterial blooms. The first is the presence of nutrients. So especially phosphorus is a big one. So phosphorus occurs naturally, but a lot of the phosphorus we see in our water sources, especially in the south, is related to agriculture and other industrial activities, but especially agriculture. So that's what's driving a lot of what's going on. But climate change can also have an impact. And that's going to be through that changing temperature, because the other thing that the cyanobacteria like is a warmer temperature. So as the temperature of the water increases, then we have a greater likelihood of a bloom happening. So, and we're seeing that all the way up to the north. So it's a big concern.
Thank you. The next question, what actions can organizations, communities, or municipalities take to reduce the impacts of climate change?
Yeah. Okay. So I'd say the number one thing is increasing, I guess they call it the resiliency or resilience of your system. But what in a lot of cases, what that means is the flexibility of your system. So whereas maybe before you could just set, a certain set point for your chemical and you could build out everything behind that based on that number. Now you have to understand that that number is not likely to stay the same. So you have to build in more flexibility into your design. You also have to have a lot more education among the people who are involved. So that goes right to the engineers who are designing things, the policymakers who are, coming up with and implementing the rules, as well as operators so that they know what's going on, right? If they observe something strange, operators are trained professionals, so they're very knowledgeable about the topic, but this is something that they might not have encountered before. And if without kind of explicit instruction and learning about these things, no one will know. One of the interesting things that came out a couple of years ago is that the design standards for Atlantic Canada were updated to include considerations related to climate change. Now I know because I used to work with the people who put this together. There was a lot of debate. There was a lot of back and forth. A lot of it was on, do we have definitive statements about like, this is exactly how climate change is going to impact things, and then therefore you have to change your design this way? Or do we encourage more education about climate change? The second option was what they went with. It seems a bit more wishy-washy, but it's also because things are continuing to change, right? So setting a set point that's like 2024 that may or may not apply in 2030. It might not apply in 2050. We don't want to like get ourselves into a situation where we've now put a new rule and it may kind of better reflect today's reality, but it's not flexible enough for the future reality. So I think that's a big one. So in terms of the rules that we choose, the education that we provide to all the professionals from that who engage in the water system from any point is really, really important. In terms of what communities can do, I guess, source water protection is always important. Making sure that those things are like actually, implemented. And a lot of that does come down to community participation, right? You can put up all the signage you want, but if people don't pay attention to the signage, it's not gonna, it's outside of anyone's control. So I guess kind of just being more engaged there, again, learning more about what the things may be. And there may be situations where we have to rethink, like, what is the zone we're protecting? What do we do for floods, right? If the river that is close to your lake or whatever is changing because of climate change and there's more flow or there's less flow or something like that, we have to be more flexible there as well, I think. So those are my thoughts. But
Thank
I'm sure
you.
other professionals would also have insights. Okay, thank you.
Thank you. Our next question, what are the potential lake level changes and impacts on drinking water and aquifers related to climate change?
Okay, so this is, I don't want to cop out, but so it's going to vary from place to place, right? And also like from place to place in terms of which direction things are going, as well as kind of when it's happening and for how long, right? So places where we're seeing more drought, we are going to see more water shortages, and that would result, that would be caused by something like a lake level change, dam, and an aquifer, which would be lower and less accessible. Um, yeah, I don't want to say definitively, other than to say that, whatever regional changes you're seeing in terms of flooding or drought are inevitably going to have an impact on your water source because we rely on the natural water cycle to replenish those systems. And not just replenish, like that's the whole cycle. That's the whole way things work. And if you change the way the cycle is working, we are going to see changes in these things, but they will be localized.
Thank you very much. Next question. Actually, so that is the final question for the pre-submitted questions. So I'm going to turn things over now to my colleague, Kelsey. And Kelsey is going to see if there's any questions in the chat that we didn't have an opportunity to answer previously. So I welcome Kelsey to join us.
There I am. Thank you, Marika, and thank you, Stephanie. I believe Stephanie covered all the questions I've seen in the chat come up so far, but if anyone else has any other questions they'd like to pop into the chat now, we can answer them. Okay, Marika, perhaps I'll pass it back to you, and if anything comes in. Thanks.
Thank you. Okay. So now we're going to take a moment to introduce a poll. So you should see on your screen, there's going to be an opportunity for us to collect some information from you. So my colleagues are going to share that momentarily. 2 minutes to select the options that best apply. Once you select your answer, hit the arrow key to move to the next question. When you reach the last question, please hit submit. If you are on a mobile device, the polls will pop up like a banner and you will have to select view to open up the poll questions. I'm going to stop sharing my screen so that everybody has an opportunity to do so. Okay, thank you very much for taking the time to fill out our polls. All right, so thank you very much for your time and attention. To host.
Oh, Marika, your volume cut out there just for a sec.
Thank you, Kelsey. I just wanted to thank everyone for time and attention.
Sorry, Marika, it's still cutting out. I can't hear you.
Okay. Hear me now, Kelsey?
Yes, perfect.
Thank you, Kelsey. Sorry, everyone, for that technical difficulties. Thank you very much for your time and attention today. We appreciate you joining us for our Drinking Water Wise webinar. We look forward to hosting more webinars in the new year, so please stay tuned and check your emails for some messages about some webinars to be scheduled in 2025. The webinar will be posted on our YouTube page in the next few days. Thank you very much again to Stephanie for your time and to my co-hosts for their time and attention as well. We wish everyone a very nice day. Thank you again.
Thank you, everyone.
Thanks, everyone. Have a wonderful day.